Now we'll discuss two important discrete probability distributions, and the first one is binomial distribution. Now, probability distribution follows a binomial distribution if it satisfies three conditions. First condition is there are n trials. So there must be something which must be repeated n times. Say for example, a coin is tossed 10 times. So in this case, we are repeating this trial of tossing a coin 10 times. So for this one, value of n is 10. Second one is each trial results in only two outcomes, either success or failure. Now, probability of success, we'll say it is P, and probability of failure is Q. So say in this example, suppose we say getting ahead is a success. So if getting ahead is a success, then probability of success is 1 by 2 and probability of failure is also 1 by 2. So there will be n trials, and for each trial we'll have only two outcomes, either success or failure, and this third one is trials are independent. That is, result of one trial is not going to affect the result of other trials. So in this case, if we toss a coin, whatever result we get is not going to impact other tosses. So any probability distribution which satisfies all the three conditions, there should be n trials. Each trial should have only two outcomes, success or failure, and trials must be independent. Then we say that probability distribution is a binomial distribution. Now here we define this random variable x as number of successes. So clearly if we conduct n trials, then value of random variable can be 0, no success, exactly 1 success, exactly 2 success, up to exactly n successes. So for binomial distribution, random variable can take any of these n plus 1 values. Now for this distribution, we have to find the probability that value of random variable x, it is equal to r. Now this probability is, out of these n trials, probability of exactly r successes. Now we have to find this probability. Now out of these n, r must be success and n minus r must be failure. First we have to select which r out of these n. So it can be done in NCR base. Now there will be r successes. So for each success, probability is p. So it will be this p into p into p, r times, because trials are independent. There will be p to the power r, and then we'll have n minus r failure. So it will be into q to the power of n minus r. So in case of a binomial distribution, probability of exactly r successes, it is given by NCR p to the power r q to the power of n minus r. And since this formula, it corresponds to expansion of q plus p to the power n, which is this summation. R varies from 0 to n, NCR q to the power of n minus r into p to the power r. We call this distribution as binomial distribution. Now since p and q are probabilities of success and failure, we know that value of p plus q is 1. So that means sum of all probabilities is 1. So this binomial distribution, it follows this binomial formula, and sum of all probabilities is 1. Now we'll come back to this question. Now it says a coin is tossed 10 times. So clearly we have n equals 10. Here p is 1 by 2 and q is 1 by 2. Now suppose it says we have to find the probability of getting exactly 2 heads. Now we have defined getting a head as success. So probability of getting exactly 2 heads. So that is, we have to find this probability of x equals 2. Now this probability is NCR. N is 10, so it will be 10C2 p to the power 2 into q to the power 8, which is 10C2, and p is 1 by 2, so it will be 1 by 2 square, and q is 1 by 2 to the power 8. Now this is 10C2 upon 2 to the power of 10, which is 45 upon 2 to the power of 10. Now suppose for same question, it says find the probability of at most 2 heads. Now when it says probability of getting at most 2 heads, now this probability is x should be less than or equal to 2, which is probability of x equal to 0 plus probability of x equal to 1 plus probability of x equals 2. Now no success, probability of x equal to 0 is 10C0 p to the power 0 q to the power 10. This is 10C1 p to the power 1 q to the power 9, and it is 10C2 p to the power 2 into q to the power 8. Now 10C0 is 1. So this is 1 by 2 to the power 10. Now this is 10, and here it is 1 by 2, 1 by 2 to the power 9, and this is 10C2, 45 into 1 by 2 square into 1 by 2 to the power 8. Now this is 45 plus 10, 55 plus 1, 56 upon 2 to the power 10, which is 7 upon 2 to the power of 7. So in this distribution, whenever we need any x equals to r, we are going to use this binomial formula. Suppose this third one is probability of getting at least 2 successes. Now here this x should be greater than or equal to 2. So it will be this probability of x equal to 2 plus probability of x equal to 3 up to probability of x equals 10. Now we know that sum of all probabilities is 1. So what we can do is, rather than finding all these values, we can simply find 1 minus probability of x equal to 0 minus probability of x equal to 1. Now this is 1 minus 10C0, 1 by 2 to the power 10 minus 10C1, 1 upon 2 to the power 10. So it will be 1 minus 11 upon 2 to the power 10, and that is the probability of getting at least 2 successes. So binomial probability questions, they are very simple problems if you can identify the 3 conditions. There should be n trials, trials are independent, and for each trial there must be only 2 outcomes, success and failure. And if we can establish that, then we can simply use this formula, probability of x equals r, which is probability of exactly r successes from n trials, is NCR p to the power r into q to the power of n minus r. Now any binomial distribution, it is characterized by 2 parameters, n and p. So generally we write binomial distribution with np. So at times you'll find questions where they'll say certain experiment follows a binomial distribution b 10 1 by 2, and this clearly n is 10 and p is 1 by 2, and once we know p, we can find q as 1 minus p. So this third parameter, it can be worked out using the value of p. So binomial distribution is characterized by 2 parameters, n and p. Now we'll find mean of binomial distribution. Now we know that mean of binomial distribution will be this summation r into NCR p to the power r into q to the power of n minus r, where r varies from 0 to n. Now we have to work this out. We know that binomial expansion of q plus p to the power n is this summation. R varies from 0 to n NCR q to the power of n minus r into p to the power r. Now what we'll do is we'll partially differentiate this function with respect to p. Now if we differentiate this function with respect to p, we can write this as n, and this is q plus p to the power n minus 1. Derivative of p is 1, and then this summation r varies from 0 to n. This is NCR q to the power of n minus r into r into p to the power of r minus 1. Now the value of p plus q is 1, so it will be this n, and we can write this as this summation r varies from 0 to n r NCR q to the power of n minus r into p to the power of r minus 1. Now we need p to the power r, so what we'll do is we'll multiply p both sides. Now we multiply p both sides, this is r NCR q to the power n minus r into p to the power r. So basically mean is n into p. So we have this result, mean of binomial distribution, it is n into p. Now we'll find its variance. Now we know that variance of binomial distribution, it will be this summation r varies from 0 to n r square NCR q to the power of n minus r into p to the power r minus mu square. Mu is n into p. So what we'll do is we'll find this summation. Now in order to find this summation, we'll use this result and we'll multiply it with p. So we can write n into p into q plus p to the power n minus 1 will be equal to this summation r varies from 0 to n r into NCR q to the power of n minus r, and we have multiplied this p, so it will be this p to the power r. Now again we'll partially differentiate this with respect to p. So here we'll use product rule. Now derivative of p is 1, so it will be this n into q plus p to the power n minus 1 plus np as it is, and it will be this n minus 1 q plus p to the power n minus 2, and here it will be this summation r varies from 0 to n r NCR q to the power of n minus r, and this is r into p to the power of r minus 1. Now p plus q is 1, so we'll write this as n plus n minus 1 into p, and it is equal to this summation r varies from 0 to n, and this is r square NCR q to the power of n minus r into p to the power of r minus 1. Now since we need p to the power r, so what we'll do is we'll multiply p both sides. So it will be this np, and here it will be this p square, and this is p. So we can write this summation r varies from 0 to n r square NCR q to the power of n minus r into p to the power r as np plus n minus 1 into p square. Now we'll put the value of this summation here to find this variance. Now this summation is np plus n square p square minus np square, and then minus mu square, and mu is n into p, so it will be this n square p square. Now this n square p square will cancel, and here if we take this np common, we'll get this as np into 1 minus p, and 1 minus p is q. So its variance will be npq. So for binomial distribution, mean is n into p and its variance is npq. So if we have to find mean and variance of binomial distribution, all we need to know is value of n and p. With n and p we can find mean as n into p and variance as n into p into q. Now there will be questions where instead of giving you two parameters n and p, they'll give you mean and variance, and from mean and variance we can work out the parameters of binomial distribution. Say for example, there's a binomial distribution whose mean is 4 and variance of binomial distribution is 2. And binomial distribution, since q is always less than equal to 1, that means n into p into q will always be less than equal to np. So this variance will always be less than or equal to its mean. Now we know that mean is n into p. So n into p is 4 and n into p into q is 2. Now we divide second with first, we'll get q, and q is 1 by 2. Now once we have q, we know that p is 1 minus 1 by 2. So it will be this 1 minus q, which is 1 by 2. And if we put p as 1 by 2, we'll get value of n as 8. So rather than giving parameters in the question, they may give you mean and variance of binomial distribution. Now here the question is, an examination consists of 8 questions, in each of which the candidate must say which one of the 5 alternatives is correct one. Now assuming that the student has not prepared earlier, chooses for each of the question any one of the 5 answers with equal probability. Now clearly this is the case of binomial probability. We have altogether 8 questions, so we have 8 trials. Now probability of getting it right, it is 1 out of 5, and probability of failure will be simply 4 by 5. Now the first one is prove that the probability that he gets more than one correct answer is. Now first one is we have to find probability that this x is greater than 1. Now probability of x greater than 1 is 1 minus probability of x equals 0 minus probability of x equals 1. Now this is 1 minus, no success, nc0, p to the power 0, q to the power n, minus, and this is nc1, this is p to the power 1, q to the power of n minus 1. Now this is 1 minus q to the power n, so it will be 4 by 5 to the power 8 minus, and this is 8c1, 8c1 is 8, p is 1 by 5 and q is 4 by 5 to the power 7. Now we can have this as 1 minus, and we'll have this as 2 into 4 by 5. So there will be 3 into 4 by 5 to the power 8, which we can write as 5 to the power 8 minus 3 into 4 to the power 8 whole divided by 5 to the power 8, which is our first part. Now this second part is find the probability that he gets correct answers to 6 or more questions. So that means we have to find this probability that x is greater than or equal to 6. Now in this case it will be probability of x equals 6 plus probability of x equals 7 and plus probability of x equals 8. Now this is 8c6 p to the power 6 q square plus 8c7 p to the power 7 q to the power 1 and plus 8c8 into p to the power 8. Now 8c6 is 28. We'll take p to the power 6 common, so we'll write p to the power 6 in the end, and here will be this q square plus 8pq, and this is plus p square. Now again p is 1 by 2 and q is 4 by 5. So it will be this 28, and then 4 by 5 is 16 upon 25, and this is 8, 1 by 5 into 4 by 5. So there will be 4 by 25 plus 1 by 25 into 1 by 5 to the power 6. Now in the denominator we'll have 5 to the power 8, and here it will be 28 into 16 plus 32 plus 1, which is 481 upon 5 to the power 8, and that is the answer to this second part. Now this third one is find the standard deviation of this distribution. Now clearly for a binomial distribution, variance is given by npq. So standard deviation will be under root of npq Now n in this case is simply 8, p is 1 by 5 and q is 4 by 5. So it will be simply 4 root 2 by 5, and that is the answer to this third part. Now the second important discrete probability distribution is Poissons distribution. Or we call it Poisson distribution. Now this Poisson's distribution, it is a special case of binomial distribution. Now binomial distribution, it changes into Poisson's distribution if it satisfies two conditions. First, n is sufficiently large. Typically, n tends to infinite. And second, probability of success, p is small. That is, p is nearly 0. Together, these conditions, where n is large and p is small, it ensures that this mean n into p, and we say, suppose this mean is lambda. So together these two conditions, they ensure uniformity of mean. Now we'll work out this formula for Poisson's distribution. Now we know that binomial distribution is this p x equal to r NCR p to the power r q to the power of n minus r. Now q is basically 1 minus p, and we'll write this p as lambda by n. So we can write this distribution as NCR lambda by n to the power r 1 minus lambda by n to the power n minus r. Now we'll write this as n minus 1, n minus 2 up to n minus r plus 1. And here we'll have factorial r, and we'll take this n to the power r here, and then we'll have lambda to the power r, and this is 1 minus lambda upon n to the power n minus r. Now what we'll do is we'll take this n with each of these brackets. So now we can write this probability of x equal to r as 1 minus 1 by n, 1 minus 2 by n up to 1 minus r minus 1 by n whole divided by factorial r into lambda to the power r and 1 minus lambda upon n to the power n minus r. Now for Poisson's distribution, we have taken the condition that n tends to infinite. So we'll take this limit n tends to infinite. Now in this case, we can write p x equal to r as, now if we take n tends to infinite, this is 0. So it will be 1 into 1 into 1 n times. So it will be simply 1. So we can write this as lambda to the power r upon factorial r, and then we have this limit n tends to infinite 1 minus lambda by n to the power n minus r. Now we check its form. This is 1 to the power infinite form. And for 1 to the power infinite form, we can directly use this shortcut. So it will be this lambda to the power r upon factorial r, and here it will be e to the power this limit n tends to infinite, and here it is gx is n minus r into fx minus 1, so it will be minus lambda upon n. Now this is infinite limit. Coefficient of n in the numerator is minus lambda, and the denominator it is 1. So it will be equal to lambda to the power r e to the power minus lambda upon factorial r. So basically in Poisson distribution, probability of exactly r success, it is given by e to the power minus lambda into lambda to the power r upon factorial r, where this random variable x, it can take the value 0, 1, 2, 3 up to infinite, because here we have taken n as infinite. So this Poisson's distribution, it is a special case of binomial distribution, and this distribution is applied if n is sufficiently large and probability of success is nearly 0. And the questions will either say a probability distribution follows Poisson's distribution, or they'll give you conditions where you'll have to use your discretion to identify whether or not it follows a Poisson distribution. Say for example, suppose we have a book of 1000 pages and probability of finding an error on each page, it is very small, then it becomes a case of Poisson's distribution, or in case of a rare disease. So in a certain population containing sufficiently large number of individuals, probability of a rare disease is nearly 0. For all these cases, we'll use Poisson's distribution. Now in case of Poisson's distribution, both mean and variance, they are equal and they are equal to lambda. So in case of Poisson's distribution, mean and variance, they must be same and they are equal to lambda. Now here it says, at a telephone inquiry system, the number of phone calls regarding relevant inquiry follows Poisson's distribution with an average of 5 phone calls during 10-minute time interval. So in this case, its mean is 5. So we'll take lambda is 5. Now we know that in Poisson's distribution, probability of x equals x is given by e to the power minus lambda into lambda to the power x upon factorial x, where x varies from 0 to infinite and it takes discrete integral values. Now we need to find the probability that there is at the most one phone call. That means we have to find this probability that x is less than or equal to 1. Now this is probability of x equal to 0 plus probability of x equal to 1. Now here value of lambda is 5. So it will be e to the power minus 5 lambda to the power 0 upon factorial 0 plus e to the power minus 5 into 5 to the power 1 upon factorial 1. So it will be simply 6 upon e to the power 5, and that's your option D. Now the next question is, a pair of fair dice are rolled independently 3 times. So in this case we have n equals 3. The probability of getting a score of exactly 9 twice. So getting a sum 9, getting the sum exactly 9, it is yours. Getting the sum 9, it's your success. And probability of success will be, now we'll get 9 when we have 3, 6 or 4, 5, 5, 4 and 6, 3. So this probability will be 4 by 36 or 1 by 9, and probability of failure will be 8 by 9. Now it says out of these 3 turns, we should get exactly 9 twice. So we need to find probability when the value of x is 2. So it will be 3c2, p2 and q. So it will be 3. Now p square is 1 by 81 and this is 8 by 9. So this probability will be 8 by 243 and that's your option B. Now here the question is, difference between the mean and variance of binomial distribution is unity. That means NP minus NPQ, it is 1. We can take NP common and then 1 minus Q, it is nothing but P. So it will be NP square and value of NP square is 1, and that's our first equation. Now it also says difference of their square is 11. So NP square minus NPQ square, it is 11. Now we can write this as NP plus NPQ and NP minus NPQ equals 11. Now this value, it is 1. So we can write this as 1, and this is NP into 1 plus Q, it is equal to 11. Now what we'll do is we'll multiply P both sides. So we can write NP square equals 11P and value of NP square is 1. So we can write 1 plus NQ is nothing but 1 minus P, and that will be equal to 11P. So we can write 12P equals 2. So value of P is simply 1 by 6. So now we have P. Value of Q will be simply 5 by 6. Now N into P square is 1. So value of N will be simply 36. If the probability that units digit in square of an even integer is 4 is P, then the value of 5P is. So now once we have even integer, it could be either 2 square, 4 square, 6 square, 8 square or 0 square. Now here it will be this 4, 6, 6, 4 and 0. Now it says the units digit is 4. Now unit digit is 4 in these two cases. That means this required probability will be simply 2 by 5 or the value of 5P is 2. That means this A, it matches with Q. So A, it matches with Q. Now for the second part it says if A and B are independent, then we are given that P intersection B is 1 by 6. Probability of A naught is 2 by 3. Then probability of A is 1 by 3. And probability of intersection B is PA into PB. Now this is 1 by 6. This is 1 by 3. And this is probability of B. So probability of B is simply 1 by 2. Now we need to find the value of 6P B by A. So it will be this 6P B intersection A upon probability of A. Now this is 6. B intersection A is 1 by 6 and probability of A is 1 by 3. So this value is nothing but 3. So B matches with R. So this B, it matches with R. Now this third one is among two children, a child may equally be a boy or a girl. If we have two children family, it could be either boy boy, boy girl, girl boy and girl girl. What is the probability that exactly one of them is a boy? So the probability that exactly one of them is a boy is simply 2 by 4, which is 1 by 2. Then the value of 6P is simply 3. That means C again matches with R. So C, it matches with R. And now the fourth question is a boy has 20% chance of hitting a target. So probability of hitting a target, it is 0.2 and not hitting a target is 0.8. Let P denote the probability of hitting a target for the first time at the nth trial. So now this probability P of hitting the target for the first time at the nth trial is q to the power n minus 1 into P, which is 0.8 to the power n minus 1 into 0.2. Or we can write this as 1 by 5 into 4 by 5 to the power n minus 1. Now we are given that if P satisfies this inequality, then the value of n is. Now we are given this inequality that 625P square minus 175P plus 12 is less than 0. Now if we factorize this, we can write this as 25P minus 3 into 25P minus 4. It is less than 0. Now critical points are 3 by 25 and 4 by 25. This is plus, minus and plus. That means P lies between 3 by 25 and 4 by 25. Now we already have P. So from here we can write 3 by 25. It is less than 1 by 5, 4 by 5 to the power n minus 1. That is less than 4 upon 25. Now this is 5. This is also 5. This is 0.6, 0.8 to the power n minus 1, and this is 0.8. Now 0.8 to the power 1, it is 0.8. 0.8 square is 0.64, and 0.8 cube will be 0.512. So the only value which satisfies this inequality is 0.8 square. That means here n minus 1, it must be equal to 2, or the value of n, it should be 3. That means this D, it also matches with R. So D also matches with R. And that is the answer to this question. Now here the question is, an author writes a good book with the probability 1 by 2, and if it is good, it is published with the probability of 2 by 3. And if it is not, then it is published with the probability of 1 by 4. Find the probability that he'll get at least one book published if he writes 2. Now this question, it is a conditional probability one. Now suppose this author, he writes a book. Then this book, it can be either good or bad. Now it is good with the probability of 1 by 2, and it is bad with the probability of 1 by 2. Now if it is good, it will be published with the probability of 2 by 3. So probability of getting it published, it is 2 by 3, and not getting it published, it will be simply 1 by 3. Now even the book is bad, then also it can be published with the probability 1 by 4. So this is probability of getting published, and probability of not getting published is 3 by 4. So from these conditions, we can work out the probability that the book will be published. So this probability that this book will be published, it is given by, now this first case, when it is good and it is published, so it will be 1 by 2 into 2 by 3, plus the second case, when it is bad and even then it gets published. So it will be 1 by 2 into 1 by 4. Now this probability will be 24, 8 plus 3. So probability of getting the book published, it is 11 by 24. Now this probability that at least one it get published, we can write it 1 minus probability that none of the book get published. So it will be 1 minus, and then will be 11 by 24 whole square, which is 407 upon 576, and that is the answer to this question. Now here the question is, numbers are selected at random, one at a time, from a 2-digit numbers 00, 01 up to 99 with replacement. An event E occurs if and only if the product of 2 digits of a selected number is 18. If 4 numbers are selected, find the probability that event E occurs at least 3 times. Now in this we have 100 numbers. So total number of numbers that we have here is 100. Now out of these 100 numbers, first we'll identify which are the numbers whose product of digits is 18. Now such numbers are 29, 36, 63 and 92. So the probability that this event E occurs, this required probability P, will be given by 4 by 100, and which is 1 by 25. Now probability of failure will be 24 upon 25. Now it says 4 numbers are selected with replacements, which makes it a case of binomial probability. Now in this case, number of trials is 4, probability of success is 1 by 25, and we need to find that out of these 4 trials, there should be at least 3 successes. So we need to find probability of x greater than or equal to 3, which is equal to P x equals 3 plus P x equals 4. Now this is 4c3 p cube into q and plus 4c4 p to the power 4 into q to the power 0. Now 4c3 is 4. Now p cube is 1 upon 25 cube, and q is 24 upon 25 plus, now this is 1 into, and this is 1 upon 25 to the power 4. Now we'll take 1 upon 25 to the power 4 common. So it will be 4 into 24 plus 1, which is 97 upon 25 to the power 4. And that is the answer to this question. Now the question is, there is a 30% chance that it rains on any particular day. So the probability of rain, it is 0.3, and it does not rain, it is 0.7. Now it says, what is the probability that there is at least one rainy day within a period of 7 days? So value of n is 7, and we need to find this probability that x is greater than or equal to 1. Now this probability is 1 minus probability that x equals 0. So it will be 1 minus, and this is 7c0, p to the power 0, q to the power 7. So the required probability will be 1 minus 0.7 to the power 7. Now the second one is, given that there is at least one rainy day, what is the probability that there are at least 2 rainy days? Now we need to find this conditional probability that there are at least 2 rainy days if it is given that there is at least one rainy day. Now this probability is probability x greater than or equal to 2 intersection x greater than or equal to 1 upon probability of x greater than or equal to 1. Now intersection of these two, it is probability x is greater than or equal to 2 upon probability x is greater than or equal to 1. Now first we will find probability x is greater than or equal to 2. Now this probability is 1 minus p x equals 0 minus p x equals 1. Now this is 1 minus 0.7 to the power 7, and here it will be 7c1. So there will be 7 and then 0.7 to the power 6 into 0.3, which we can write as 3 into 0.7 to the power 7. So this p x greater than or equal to 2 will be 1 minus 4 into 0.7 to the power 7. So this conditional probability will be 1 minus 4 into 0.7 to the power 7 divided by 1 minus 0.7 to the power 7, and that is the answer to this question. Now here the question is, the probability that a missile hits a target successfully is 0.75. Now in order to destroy the target completely, at least 3 successful hits are required. Then the minimum number of missiles that have to be fired so that probability of completely destroying the target is not less than 0.95. Now probability of success in this case is 0.75, which is 3 by 4, and probability of failure will be simply 1 by 4. And suppose number of hits is n, then this probability that target is destroyed will be given by p x is greater than or equal to 3. This probability is not less than 0.95. That means it should be greater than or equal to 0.95. Now we can write probability of x greater than or equal to 3 as 1 minus probability of x less than or equal to 2, and it should be greater than or equal to 0.95, or we can write probability of x less than or equal to 2, it should be less than or equal to 0.05. Now this is probability of x equal to 0, so it will be this nc0 p to the power 0 q to the power n plus nc1 p to the power 1 q to the power of n minus 1 plus nc2 p to the power 2 q to the power n minus 2, and will be less than or equal to 0.05. Now this is 1 by 4 to the power n. Now this is 3n upon 4 to the power n, and this is n minus 1 into 9 upon 2 into 4 to the power n, and will be less than or equal to 0.05. 0.05. Now if we take LCM, we can write 2 plus 6n plus 9n square minus 9n. It should be less than or equal to 4 to the power n divided by 10. Or we can write this as 9n square minus 3n plus 2. It should be less than or equal to 4 to the power n divided by 10. Now we can rearrange this as 5 into 9 to the power n minus 3n plus 2 will be less than or equal to 2 to the power of 2n minus 1. Now we just have to put the value of n to check. So what we'll do is we'll check it around 3 and we'll see if we need to increase the value of n or decrease the value of n. Now if we take n as 3, we'll get this as 2 to the power 5, 32, and here it will be 81. 81 into 5 will be, so what we'll do is we'll check n as 5. Now if we put n as 5, here we'll get 2 to the power 9, and 2 to the power 9 is 512, and here will be this 25 into 9, 225 minus 15 plus 2. Now this value is again greater than 512. Now if we look at n equals 6, for n equals 6, this value will be 2 to the power 11, and 2 to the power 11 is 2048, and here this value will be 5. 9 into 36 minus 18 plus 2, and here left hand side is 1540. So that means the smallest value of n for which this left hand side it is less than right hand side, it is 6. So answer to this question is simply 6.
Now question number 7 is success in a roll of 6-face balanced die is defined as hitting a 6. So probability of success is 1 by 6. That means probability of failure is 5 by 6. Now it says let P denote probability of success if the probability of obtaining at least one success in n repeated rolls is greater than or equal to 0.9. So that means probability that x is greater than or equal to 1, it is greater than or equal to 0.9. What is the smallest possible value of n? Now we know that probability of x greater than or equal to 1, it is also written as 1 minus probability of x is equal to 0, and it should be greater than or equal to 0.9, or probability of x equal to 0, it should be less than or equal to 0.1. Now probability of x equal to 0 is nc0, p to the power 0, q to the power n, and will be less than 0.1. Now q is 5 by 6 to the power n, and will be less than 0.1. Now if we take log and solve, we'll get this n, it should be greater than or equal to 12 point something. So basically the smallest possible value of n must be 13, and that is the answer to this question.
Negative question is a multiple choice examination has 5 questions. Each question has 3 alternatives, out of which exactly 1 is correct. So probability of success is 1 by 3, probability of failure is 2 by 3, and altogether we have 5 such questions. So basically it's a question of binomial probability. Now we need to find the probability that student will get 4 or more correct answers. So we need to find probability of x greater than or equal to 4. That will be probability of x equal to 4 plus probability of x equals 5. Now this is 5c4 1 by 3 to the power 4 into 2 by 3 plus this is 5c5 1 by 3 to the power 5. Now 5c4 is 5 into 2, and this is 1 divided by 3 to the power 5, which is 11 upon 3 to the power 5, option C. Now this again is a Poisson's distribution question. Now mean here is 2. We have to find the probability that x is greater than 1.5. Now x cannot take decimal values. So basically this is probability of x greater than or equal to 2. Now we can write this is 1 minus probability of x less than or equal to 1. So it is 1 minus p x equals 0 minus p x equals 1. Now we know that in Poisson's distribution, x equals x is e to the power minus lambda, lambda to the power x upon factorial x, where lambda is average. Now average in this case or mean is given as 2. So it will be 1 minus e to the power minus 2 to the power 0 upon factorial 0 minus e to the power minus 2 to the power 1 upon factorial 1. So it will be 1 minus 3 upon e square, and that's your option C.
Now the question is, an unbiased coin is tossed n times and let x denote number of times head occurs. If p x equal to 4, x equal to 5 and x equal to 6 are in AP, then the value of n can be. Now p x equal to 4 is nc4, p to the power 4, q to the power n minus 4. This is nc5, p to the power 5, q to the power n minus 5, and this is nc6, p to the power 6 and q to the power n minus 6, and it says they are in AP, where p is 1 by 2 and q is 1 by 2. Now since p and q, they are all 1 by 2, so this factor in all the three cases will be 1 by 2 to the power n. So we can simply write 2nc5 1 by 2 to the power n equals nc4 1 by 2 to the power n plus nc6 1 by 2 to the power n. Now 1 by 2 to the power n will cancel. Now what we'll do is we'll divide everything with nc5. So this is 2 and this is nc4 upon nc5 plus nc6 upon nc5. Now n is same, r differs by 1, so we can write this as n minus r plus 1 upon r, and here also will be n minus r plus 1 upon r. So it will be this 2 and then 5 n minus 4 plus n minus 5 by 6. Now if we simplify this, we can write this as 12n minus 48 will be this 30 plus n square minus 9n plus 20. So it will be this n square minus 21n plus 98 equals 0. Now this is 14 into 7 and 14 plus 7. So if we solve this, we'll get value of n as either 7 or 14. And that's your options A and D. Now here the question is, indicate the correct order sequence in respect of the following. Now the first one is, if the probability that a computer will fail during the first hour of operation is 0.01, then if we turn on 100 computers, exactly one will fail in the first hour of operation. Now we are given that value of P is 0.01, value of N is 100. Now P x equal to 1, it is given by 100C1, P to the power 1 and Q to the power 99, and it is not equal to 0.01. So that means this first one, it is false. Now what about the second one? Now second one, it says a man has 10 keys, only one of which fits the lock. He tries them in a door one by one, discarding the one he has tried. Now we need to find the probability that fifth key fits the lock is 1 by 10. Now first one, it should be a failure, so it will be this 9 by 10. Second one, it will be 8 by 9. Third one, 7 by 8. Fourth one, 6 by 7. Now this fifth one has to be the right key, so it will be then 1 by 6. So this probability will now be 1 by 10. That means this second one, it is true. Now this third one is, given that events A and B such that PA equals 1, then A and B are independent. Now we know that if PA equals 1, then B is a subset of A, then probability of A intersection B, it will be equal to probability of B. Now we can also write this as
probability of A intersection B into probability of B into 1, and this 1 is nothing but probability of A. So we can write this as probability of B into probability of A. So that means this third one is also true. Now the fourth part is, when a fair six-sided die is tossed on a tabletop, the bottom face cannot be seen. The probability that product of number on the 5 faces that can be seen is divisible by 6 is 1. Now, if the bottom face, which is not visible, it is 6, then too we have 3 into 2 in the product. That means this product will always be divisible by 6. And if it is not 6, then in that case, it will have 6 on one of the face. Therefore, this product will again be a multiple of 6. So it is true for any case. So this probability will always be 1. So that means this fourth option is also true. So answer to this question is false, true, true, true. And that's your option B.